Good morning, everybody. It's time for chemistry with your host, me, Dr. White. Hopefully, you've had a good time since we last met. One thing I should mention, as I would if we were in COD on campus having a lab, the day we have the lab, today, I'll be talking about it later today, that's when I pass back the labs you did last week, which you already handed in. Well, I can't pass it back to you because, no, I can't put my finger through the screen. And Dr. White's being so, it's awful humor Thursday. You got to suffer with that. So do I. But, anyways, I have uploaded your lab scores for lab 1 in Blackboard. If you don't see a number there, you didn't hand it in. And therefore, also, you've heard me say, and I'll say it again, there's no such thing as a dumb question. And that also pertains to anything I put a score on or grade. You can always ask me, why did I get this grade? Or better yet, what was the reason I got this grade? And I will always explain it to you. Because like I said, there's no such thing as a dumb question. If you ever have a question about why I graded something a certain way, ask. Now, a week from today will be test 1. I didn't have a chance because I've been super busy with a lot of things to post it, but by Saturday morning, I will have posted as an announcement, check your email daily, the information about test number 1. I will tell you, I'll cover chapters 1 through 4, and I'll put down how many problems, how many pages. Historically, when I rewrite my test every semester because I let students keep the test. If we were on campus, you would get to keep your test. I will put down how many pages, what kind of problem, or actually for test 1, I usually have about 6 to 10 multiple choice questions, 1 point each, and the rest are small answers or things like that, like, what's the charge on an electron? Negative. That would be a question on a test. And someone asked me last night, and I should tell you a secret. On a lab, on a test, Dr. White always gives you much more room than you'll ever need to write an answer. Even if it's one word, I'll give you way more. If you want to fill it up, you can, but you don't have to. I don't grade by weighing your labs. When I was an undergrad, we had a suspicion a teacher used to do that, weigh our labs to give our grade. The more pages, the better the score. I don't do that. All right, now, your colleagues, one of your colleagues had a very important question that she told me that she and other of your colleagues had concerning a couple things in my class. Before I answer those questions, I should tell you there's no such thing as a dumb question. Always feel free to ask me questions about anything. Doesn't mean I'll always answer it, like I'm not going to give you my social security number, but anything else, I'll answer it the best I can. All right, first concern, and that is when I changed to the newer syllabus, I changed the logon URL for my office hour. Make sure you use the right one. My office hours are always Monday and Wednesday nights from 6 to 7:15. Now, because we're on Zoom and I have Zoom access, if you ever need special help, let me know. And if I can manage it, we'll meet together on Zoom. But I'd rather we stick to the office hours because I got other things I do in my life, like consult. All right, that's number 1. Number 2, if you look at the syllabus and look at the labs, you'll see a date. Week 1, certain date, week 2, week 3, week 4, and so on. That's the day that of that week or that date, I will be talking about the lab. Just like if we were going into a laboratory at COD, that would be the actual lab you're doing that day, and it's always due the next week, okay? And I think I covered all the questions. If not, someone chime in. Let me know if you have any other questions, because it's time for Dr. White to take questions. Anything else? I think I covered everything. If not, let me know and we'll do it. All right, let's get to work. We got a lot of work to do. We're going to go through the problem set for chapter 3, and we'll go through finish up chapter 9 probably today, maybe get into chapter 5. That's going to be on test 2 next Tuesday. I will be going through the problem set for chapter 4, and then I will be giving my world famous review for the next test, which in this case is test number 1, which you know it was world famous. It is. But anyways, let's get to work. Hold on, now I'm trying to find some, here it is. Nope. All right, since Zoom's been playing games with me, everybody see Dr. White chapter 3 practice problems on your screen? All right, let's try it again because it tells me you should. All right, now do you see it? All right, like I said, Zoom plays games. All right, let's go through this. All right, I see everybody now sees it. All right, practice problems after test number 1. You'll find out why I call these practice problems. Hint. All right, first one. What I normally like to do is go through a page at a time. And if you have any questions, let me know which ones you want me to do, or I'll pick ones myself. And I'm going to start with number 1. What is one of the 4 branches of chemistry? And you only have to pick one or say one. My favorite is organic, and you can see the other 3. Next, an important one, what are the 3 states of matter? And they are, everybody together, solid, liquid, gas. And you should know, I don't ask it here, but you should know solid has definite shape and definite volume. Liquid has indefinite shape but definite volume, and a gas has indefinite shape, indefinite volume. Now, we talked about some definitions. Name a pure substance you could use in your life. Many of them, water, gold, oxygen, nitrogen you're breathing could be pure. Name a mixture that you could purchase at your local grocery store. Milk is a mixture, mouthwash, pop, mustard, and the list goes on and on and on. Now, I'm not sure if I mentioned this, and I'll do it now, and I'll do it again on Tuesday, about homogeneous and heterogeneous. Homogeneous, homo, the same, hetero, different. And homogeneous means it's a mixture where it's the same throughout. Heterogeneous, it's not the same. And I ask, is oil vinaigrette dressing a homogeneous or heterogeneous? Have you ever had something like, and I don't buy it anymore, I make my own, wishbone salad dressing, oil and vinaigrette, which is this vinegar that's got spices in it. If you let it sit, it separates into 2 layers. And that's why it's heterogeneous. Gasoline, if you ever see a sample of it, it's all the same throughout. You don't ever want to buy heterogeneous gasoline because that'll destroy your engine. You want homogeneous, your car engine. All right, I asked you to learn certain chemical symbols and their names. Remember the periodic table you'll get will look like this. And let's get back to here. Let's do one. Give the chemical symbol for, oh, let's go to the high rent district. Gold, AU, or sodium, Na. You should know how to do all 37 that I gave you. How do you learn that? Write down the symbol and say it 5 times. For carbon, you should write down the word carbon, write down the letter C, and either out loud, or if you're in the library, well, you wouldn't be in the library because it's closed. But if you were in a place where it had to be quiet, in your mind, think carbon C, and then do it again 5 times. Do it a second time a day or two later, it's in your mind for good. And the other thing is, I said, going both ways, if I ask on a test, give the name of an element with the following chemical symbol, and I put down Mg, you should know that's magnesium, Kr, that's krypton, and remember, unless I've been hijacked or kidnapped to another universe, alternative universe, in our universe, krypton is a clear, colorless gas at room temperature, not a green solid that kills Superman. Now, we talked about physical and chemical properties. Water freezes at 0 degrees C, which you found out, and hopefully you're close to that, depending how accurate your thermometer was. Is that a chemical or physical property? And because water doesn't change when that happens, it's a physical property. If we look at iron can rust, is that a chemical or physical property? And that describes how it changes into something else. Iron is Fe, rust is Fe2O3, ferric oxide, also known as rust. So that's a chemical property. Gasoline is flammable, that's a chemical property. Give an example of a chemical change. That's when you do something to some substance and it changes its chemical identity. In other words, you make new substances. Example, I bet you didn't think about it, but when you burn a candle and you have that flame on top, you're watching a chemical reaction, and the wax is being converted into other chemicals, carbon dioxide and water. Not to scare you, but when you digest food, you chew your food. By the way, 2 things. When I was little, real little, like about 2 years old, my mother used to say to me, I can remember sort of, don't forget to chew your food before you swallow it or you'll choke. And guess what? I found out the hard way she wasn't lying to me. Oh, good news, I survived. The other thing is, when you do swallow it and it goes in your stomach, mine's down there, and guess what? It's undergoing chemical changes. It's being converted into other things. And that's how your body breaks down food to give you nourishment. By the way, that's about all I know. Well, I know the chemistry, but the last time I took biology was freshman year of high school. Wow, that was eons ago. But nothing wrong with biology, but by then I knew I wanted to be a chemist. Now, the other thing, when I think about candles, and I should have brought one up, I used to work for an Anglo-Dutch company. I went to Netherlands a lot, and this company's headquarters and research center was in the city in the Netherlands, as spelled Gouda. You pronounce it the American way, Gouda. Nope, Dutch is, that's Gouda. G is a hard CH in Dutch. I know some Dutch, but most of them speak English, so I never got the opportunity to really master Dutch like I wanted to, because they all wanted to speak English. And in Gouda, in the town center, first of all, the town hall and the cheese, which Gouda is famous for, Gouda cheese, you know it by, it's really Gouda, the cheese warehouse. It was already 100 years old before Columbus set sail, beautiful city. And in that town center, they had a shop that sold hand-dipped candles. And I have a collection of them. I don't think I'll ever burn them. They're about way tall, this diameter. You can see the layers where they're hand-dipped. Beautiful. Maybe someday I'll bring one up from downstairs or in my family room. All right, back to chemistry. And if we look here, I asked you to learn things about definition of solid, liquid, or gas. What state of matter has definite shape and definite volume? Solid. Next one is gas. For a liquid, 19. And that's this problem set. Before I move on to the second part of chapter 3 problem set, I'll ask everybody, do you have any questions about what I just went over? Going once, going twice. Done. Oh, by the way, I was going to say, and I was going to do a monster generation gap. Does anybody out in the peanut gallery have any questions? By the way, that comes from, I didn't like it, but it was very popular. A lot of my friends watched it, but I didn't. A couple of my best friends didn't either. The Howdy Doody show. It's somewhere on YouTube. You can find it. It's about this puppet. And they had kids live, and they'd always say, hello to the peanut gallery. Why I called it a peanut gallery, I don't know. Let's go back to chemistry. That I do know. All right. Hopefully, and let me ask my thumbs up people real quick. Do you see temperature practice problems? Thank you. All right, let's go through this. If the temperature of a liquid is 134 degrees C, what's the temperature in degrees F? Now, the way I like to do, and take a deep breath, relax. I'm going to use a scary word, this word problem, relax. I like to find out, first of all, what am I being asked to find? I use a question mark. You don't have to do this on a test, but I found this helps me get the right answers, and students of mine get the right answers, which I think is a good thing on a test. Degrees F, what are you given? You will be given a series of formulas. If you look in the lecture section of Blackboard near the bottom, and I'll cover it next Tuesday, you'll see important information for test number 1. And this is one of the formulas you'll be given, but you got to know how to use it, when to use it. And here, since we want to go to degrees F, we use 1.8 times degrees C plus 32. I'll put that in there, do the multiplication first, and then the addition. Now, since you have a formula up here, 1.8 and 32 are exact numbers. Exact numbers are never used to determine significant figures of an answer of a calculation. On tests 1, 2, 3, 4, and the final, underneath your name, it will say, please use proper significant figures for all calculated answers. If you don't, and say that this was a 3 or 4 point question, I take off a point. So let's take a look at it. Notice this is 3 significant, and I rounded this off to 3 significant. We go to number 2. It's the same thing. I give multiple chance for you to try. Let's look at number 3. This is a little different. Again, read the problem and determine what are you being asked to find. And here we're given, if your oven is 353.5 degrees F, what's the temperature of your oven in degrees C, Celsius? And therefore, what are we being asked to find? Degrees C. What are we given? Degrees F. Therefore, you need to use this formula. Degrees C equals degrees F minus 32 divided by 1.8. All right, everybody, pay attention. Common mistake on test 1. Students look at this formula and divide degrees F by 1.8, then 32 by 1.8, and do the subtraction. And guess what? You get the wrong answer. Wrong. You do the subtraction before the division. I'll say it again in slow motion. You do the subtraction. Dr. White's being silly, but seriously, you do the subtraction before you do the division. So if I do this and I do this subtraction and then the division, my calculator will give me a lot of numbers. By the way, you should practice using your calculator in both scientific and regular numbers. And if you're not sure, come to my office hour next Wednesday or Monday. But 32 and 1.8 are exact numbers. They're part of the formula. They play no role in determining significant figures. Therefore, the only number that determines significant figures of your answer is 353.5. All non-zero numbers are significant. There are 4 of them there. Therefore, my answer, as you can see, has 4 significant figures. If you put down 179 or 178, I'd take off 1 point. Now, another thing that I haven't mentioned, but now's the time. Do you have to show your work? No, you could have just put down 178.6. However, what if you hit the wrong button on your calculator and you put down 182? But you have all this written down and you put the wrong number there. I'll say, oh, you made a math error somehow, and a 4-point or 3-point question, or even more, a 10-point question, which this wouldn't be, but later on you might get some. I will only take off 1 point because you made a math error. You showed me you knew the chemistry. So it always pays to show your work on a test of mine, always, which is another reason why I don't like multiple choice. And I'll never ask you to do a calculation for a multiple choice problem, because what if you do hit the wrong button on a calculator? You lose all points. That's not right, at least in my mind. All right, let's look at number 6. And that is, if the temperature of a liquid is 101.5, then what is the temperature in degrees C? What is the temperature in Kelvin? For one of these days, I'll have to look it up, not this week, why they don't call it degrees Kelvin, but they don't. That's one of the few things I don't know in chemistry, but one of these days I'll learn. So what are we being asked to find? Degrees, or Kelvin, not degrees, just Kelvin. What are we given? 101.5. This will be important information. You need to know that this is the formula you use. Kelvin equals degrees C plus 273. This is a definition. Therefore, 273 is an exact number. It does not determine how many significant figures your answer should have. This has 1 past the decimal. It's an addition. Therefore, I have 1 past the decimal. And that's how you do it. And we're done. Someone asked, are you allowed to use calculators during the test? Yes. Are you allowed to go and get into study groups with other people? No, that's called cheating. And I hope you don't. By the way, if you haven't figured it out by now, Dr. White is a power user on computers and software. I got my first PC when I worked for a company. It was at CHEMI back in 1984. Oh, wow, I shouldn't have said that. Back then, PCs had just come out. IBM came out with the first PC. And I was the first one worldwide in that company outside of accounting group to get a PC, because I realized this is going to be very important for me to know how to use. And I convinced the president of the company to give me one. Well, I found out that was a mistake in one way, because all the other research section heads were like little 5-year-olds. How come Dr. White got one? I don't get one. Oh, were they mad at me? It took about a year or two before that blew over, but I'm a power user. I have certain things in my test that I'll know if people are cheating. If you haven't figured out by now, I'm pretty laid back. There are 2 things that get me upset, and I don't like being upset, so that's bad. One is people who lie to me, and 2 people who cheat. Cheating is just, in my book, another form of lying. I will do what's in my syllabus. I have done that at COD. I get the dean of students and my dean involved very quickly. All right, let's move on to happier things. It's time to get back to chapter 9. Now, since Blackboard already on Blackboard, Zoom's already played games. Everybody see Electron Shell on the screen? Thank you. Thumbs up, people. All right. We talked about Electron Shell and subshell on Tuesday. Electron shell is a space where it contains electrons approximately same energy, same distance from the nucleus. Each shell has subshells where electrons have exactly the same energy and are exactly the same distance from the nucleus. Remember, the nucleus is the center of the atom with protons and neutrons, but now we're talking about surrounding that, the electrons. Talked about the electron shells, and they have very difficult numbers, shell 1, 2, 3, 4. Also, shell 1 has 1 subshell, the name gives it away. Shell 2 has 2 subshells, 3, 3, 4, 4. I think there's 5 and 5, I don't know. I've never gone that high, and in a while you'll see why. All right, now the subshells, which are also known as orbital designations, have letters S, P, D, and F. S is the lowest energy, F is the highest. Going from S to F, you increase the energy of the subshell. I'll never ask on a test, but a student asked once, what do those letters stand for? And they come from atomic spectra, and they stand for sharp, principal, diffuse, and fundamental. How they got that, I have no idea. Because atomic spectra, other than undergrad, I've never worked in industry. Had people run them for me, but like this chart right here, that will be in important information test 1. I used to make students memorize it. I don't anymore, but you have to know how to use it. This chart will also be on important information, and that is orbital or subshell. S can only take, maximum you can put in there 2 electrons, P 6, D 10, F 14. That's the maximum. You can put less than that, like in S you can have either 1 or 2, but you can't have 3 because you just can't, because it doesn't exist. When I say you can't, that means all the elements have been examined and not one element has found, as a scientist, chemist found, S to have more than 2 electrons. Same thing with P with 6 and so on. I'm skipping orbital in this class, so I'm going to skip this slide. Here's shapes. I'm going to skip this, even though this plays an important role in certain things in our daily life, like the p orbital plays a role why cis and trans fats. One is healthy for you, cis. One is not healthy for you, trans. Yes, the p orbital of electron plays a role there, but that's in organic chemistry. Electron, now, this is important. Electron subshells are filled in order of increasing energy. The lowest level is always filled first. Same thing with the shell. Now, forget about orbitals. I'm not going to cover this. I should have taken this off. Now, I'm going to steal something from the movie Spinal Tap again. If I could turn a dial only up to 10, for this next slide, I've really just turned it up to 20. Hint, know this. All right, There's a way of doing accounting for electrons in chemistry. There are two ways. One is called the electron configuration, which I will teach. The other is called orbital diagrams. For this course, I'm going to omit. Now, electron configuration is a statement of how many electrons an atom has in each of its subshells. And hint, we're talking about numbers and letters only, or numbers, letters, and superscript numbers. I could also see board for examples. Oops, I better get to work. Sometimes I write drawer. Lately I've been doing give the electron configuration for hydrogen. Well, what do you have to do? Well, first of all, you have to find out how many electrons hydrogen has. So how do we do that? We go to our periodic table. Hopefully you all see a periodic table there. Let me blow this up a little. And you look, here's hydrogen. How many electrons does hydrogen have? 1. So we know we have hydrogen has 1 electron, and I'll abbreviate it like that. Well, how do you begin? Well, what's the first shell? 1. What's the subshell? There's only one, 1s. Remember, a subshell is denoted by a number and a letter. A subshell is denoted by a number and a letter. How many electrons do we have to put in there? 1. I'm done. This is the way you do that. Let's do another one. Let's take a look at the periodic table and find a good one. Oh, I got a good one. By the way, this is my favorite element on the periodic table. And if I were to ask you to draw the electron configuration for carbon, what do you do? Well, first of all, you have to find out how many electrons carbon has. And how do you do that? You go to your periodic table. And this is the one you should be using. You shouldn't be looking on the internet. And carbon is C. The atomic number tells you how many protons, electrons. We're looking for electrons, and that number is 6. So we now know we have 6 electrons. Normally, as COD, I'd be writing this on the whiteboard along with this problem, so I might as well do that here. See, Dr. White knows his chemistry. All right, let's do this. How do we do the draw the or give the electron configuration of carbon? Well, we have 6 electrons to put in. What's the first shell? Remember, you always start at lowest and go to highest energy. Therefore, the first shell is 1. What's the first subshell of 1? Again, you always go lowest to highest, and that's S. Remember, 1 only has 1 subshell, and that's S. How many electrons can I put in S? 2. Will I do that? Am I done? No, I have 4 more to go. How many subshells in 1? 1. Well, I filled it up. Now I have to go to the next subshell, and that's 2. And what's the first subshell in 2? 2s. How many electrons can I put in 2s? Any s orbital, you can put 2. Well, can I put any more electrons in 2s? No, I filled it up. Am I done? No, 2 plus 2 is 4, and I need to get to 6, so I've got more. How many subshells does 2 have? And the answer is 2. The first one is S, the second one is P, which we denote by a number and a letter. Remember, subshells are a number. That's an awful looking P. Hold on, don't look. Oh, you looked. That's better. And how many electrons can I put in? 2p or 3p or any p orbital? And the answer is 6. Remember, you don't have to memorize it. These 2 tables will be given to you. But do I need 6? No, because I have 2 plus 2, that's 4. I'm trying to get to 6. So 6 minus 4 is 2. 2, 4, 6 electrons. I could have put more, but I don't have them. And this is how you do that for carbon. All right, Dr. White's going to share the fun, but first I'm going to help you out. Draw the orbital diagram for oxygen. And what you have to figure out first is, how many electrons does oxygen have? How do you do that? Look at the periodic table. Oxygen has a chemical symbol, which hopefully you know by now, hopefully you know for next week, is O. How many electrons does oxygen have? 8. Remember, atomic number tells you how many protons and electrons. Everybody see the whiteboard now? Okay. So, hold on one second. Let me just write that. You have oxygen, 8 electrons. I'm going to lower this so you can see the charts. And while you're doing that, I'm going to check. Nope, that didn't do it. Let me do one thing and I'll bring you back in a second. All right, thank you for telling me yes. And you try it. This is tough, so if you're having troubles, relax, takes practice. Also take some tea. If we were in class, I'd say, when you're done, look up and smile. But some of you don't have your webcams on or don't have webcams right now. So give me a thumbs up when you're done, either on your video or with your little button at the bottom. Take your time. When you're done, give me a thumbs up. Give you another minute. If you finish early, please be patient. I try and give everyone time to finish. All right, anybody need more time? Going once, twice? All right, let's get to work. Question is, draw or give the electron configuration for oxygen. You have 8 electrons. What's the first orbital? And that is, or first subshell, 1s. How many electrons can you put in any s? 2. How many subshells does shell 1 have? 1. Well, I filled it up because the subshell is 1s. It's got 2 electrons. Any s orbital can have only 2 electrons. So now I go to the next shell, which is 2. What's the first subshell in 2? And a subshell is a number and a letter, and that would be 2s. How many electrons can I put in 2s? And the answer is 2. Well, I can do that, and I am. Am I done? No, I have 2 plus 2 is 4, and I need 8. How many subshells does shell 2 have? Oh, it says right here, 2 of them. The first one is 2s. What's the second one? 2p. Ooh, it's a better P I wrote. And I'm getting the hang of this drawing tablet. How many electrons maximum can I put in 2 in any p orbital? 6. Now, 2 plus 2 is 4. I have 8. 8 minus 4 is 4. And therefore, I'll put in 4. Oh, it rhymed. Therefore, I'll put in 4. And this is the electron configuration, which is 1s2, 2s2, 2p4. And that's how you do it. Remember, you always fill the lowest energy shells and subshells first. Then you go down this chart. Next, any subshell is designated by a number and a letter. And that's how you do it. It's time for a little gift from Dr. White. Remember, don't give it away to other people. But what's the little gift I'm going to give you? Watch closely. First of all, I see some questions. All right, in my first chart, the first column is shells. The second column is subshells, number of subshells. If you go to my notes, and I'll go there in a second. Someone asked, can we just put 2p4 and assume the others? On my test, I don't assume, and you shouldn't assume. I'd mark it wrong. I'm going to do another electron configuration. So if anybody was confused, I'll help you out. We'll do it again. And let me now give you my gift. Right now, you should see the periodic table on your monitor. Everybody see it? Okay. Now, when we start doing electron configurations, when you get down to the higher elements, some of the rules break down. And you may do a 4S before you do a 3D. And there are all sorts of exceptions. Is it worth our time to memorize all that and spend a week or two learning that? No. Therefore, my gift to you is for electron configuration, you only have to know how to do up to magnesium, 1 through 12 in the periodic table. The rules follow exactly. And you'll see later today or next week what's more important than electron configuration, even though it is important, which is why I'm teaching it to you. Since none of you are going to be chemists, and I'll be honest, I don't even use this stuff. I use what I'll teach you later that was more important. I'm not going to waste a lot of my time and your time, more importantly, your time, having you learn something that all the exceptions that you'll never use again. But you should know, hint for my test, how to do electron configuration for 1 through 12, hydrogen through magnesium. And that's my little gift to you. It turns out it's a pretty big gift. Make your life so much easier. Now, someone asked, could I do another one? Actually, they said they were a little confused, and that's allowed. The first time I learned this, I was a lot confused. It took me a while to get my hands around it. I like those visual cues I'm doing. But anyways, let's do another one. And let's go back to our periodic table. Oh, let's go one of my favorite elements, sodium. And if I were asked on a test, draw the electron configuration for sodium. The first thing you have to do is how many electrons? Because for electron configuration, I just looked at the clock. Guess what? Time flies when you're having fun with chemistry and Dr. White. It's time for a 5-minute break. I'll see you in 5 minutes at 10:55 because I'm going to stretch. And when I come back, I will do sodium electron configuration. Ring, 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 ring. Everybody come back to this classroom. Or better yet, I haven't used it all day. I've got to. Back to class. All right. It's amazing how time flies when you're having fun with chemistry. It does for me. All right. I'd asked, how do you draw the or write or give the electron configuration for sodium? And we determined that sodium, I'm going to do this one. So everybody will understand. And let's go to my whiteboard. And let's go through this table again. I'll try and write it bigger. And there, if I were in class, you'd be watching me write on the board like I'm doing now. I guess this tells you, all right, here we have, let's call it one from column A, one from table B. All right, table A tells you the shells and the number of subshells in each one. Table B tells you each subshell, and I better put in the numbers, how many electrons max that you can put in each one. S2, that's better. P6, D10, F14. Now, because of my little GIF, you only have to know up to S and P. Same thing here, my gift, you only have to know up to shell 3. But let's do sodium. Na, you don't have to write that down, but you have to know the symbol to find how many electrons. How many electrons? 11 electrons. What's the first shell? Now, why do we do this? Look out, is warning, warning, time for Dr. White artwork. Let's say you had a dresser, and by the way, don't hurt yourself laughing, and it has different drawers here. And being the lazy person I am, you got something, I don't want to bend over, I'm going to put it in the first drawer until they're all filled up. And then I'll go to the next one, that's filled up, and the lower I have to bend, the more it hurts my back. So I'm going to try and fill the stuff in the top first. Well, if this drawer only has so much you can put in, well, once you fill it up, you got to go to this one, and so on. Well, it's the same thing up here. Think of a shell as a drawer, and in each drawer you have subshells. And shell 1 has only one subshell, and you can only put 2 electrons. Look at them. So 1 has one subshell. You always go lowest to highest energy when you're filling it up, just like on your drawer or dresser here, what's easiest to fill up first. So if we come over to sodium, we have 11 electrons. What's the first shell? 1. How many subshells does 1 have? 1, and that's 1s. How many electrons can we put in any s orbital? 2 max. I'm going to do that. I filled up that drawer. Actually, it's a subshell and shell. So now shell 1 only has 1 subshell. I filled it up, so I now have to go to shell 2. Shell 2 has how many subshells? 2. What's the lowest energy one? 2s. Remember, a subshell is a number and a letter. How many can I put in 2s? Well, any s orbital, you can only put in 2 electrons. See, it says right here. Remember, you got to believe everything you see on the internet. No, not really. Oh, it's super bad humor time. Look out. But anyways, this is full. I have 4 electrons, 2 plus 2, but I'm trying to get to 11, so I got more to go. Well, 2 has 2 subshells. The first is 2s. The next one would be 2, and then the letter P. How many electrons can I put max into 2p? 6. Well, yeah, I need 6. Now I have 2 plus 2 plus 6. That's not 11. How many subshells does 2 have? 2. And I fill them up. Just like the dresser here, I have to go to the next shell. And that's 3. What's the first shell and subshell in 3? Always S, and remember, subshell is a number and a letter. Now, how many electrons maximum can I put in there? 2. But I've got 10 here. And let's see if I can do my high-level math. I have 1 left to go. Well, I can put it there because I could put up to 2 in a 3s, but I only need 1, and now I'm done. Sodium, 1s2, 2s2, 2p6, 3s1. And that's how you do it. Does that clarify things, make it a little better? Don't forget, the first time you're learning it like today, it's not easy to wrap your hands around it. It took me where I had to do my own practice problems. So everybody, take a deep breath. Relax. Take a deep breath. Don't you feel better already? Now, if you look, remember what I'm doing. You're welcome, Kim. Now, what I'm doing now is not on test 1 next Thursday. It's on test 2. You got plenty of time to practice this. When we get to it, you'll see the practice problems for chapter 9. I have you doing these, and we'll go through that later. Hold on, tea break. I mentioned it, but I'll mention it again. Every question I put on a test, except what's your name, I will go through in my lectures at least twice the concept behind that question. I never just say, here's the stuff, learn it on your own. Dr. White doesn't do that. In fact, if you drill down, I think it's in this school, I didn't come up with it, and I thought it was very nice and true about me. A student said, Dr. White never assumes you fill in the blanks in his class because there are no blanks. At least I try not to. All right, I see a question. I got that already. You're welcome. All right, let's move on. We're going to come back later on to this when we do the practice problems, but I like to move on. Now, I didn't take out orbital diagram. That won't be on the test. Hold on. Let's make it official. Whoa. And now you have it in writing from Dr. White. This won't be on the test. I used to, but there are more things I would rather talk about. All right, let's talk about the periodic trends of the elements in the periodic table. Now, certain properties increase or decrease as you move across the row or down the family. And I'm not going to really get into that, maybe at the end of this chapter, but we'll talk more about it later on. Now, if I had a dial on my amplifier that I could only turn up to 10, I've just turned it up to 50. The next thing I'm going to talk about is extremely important in chemistry to Dr. White and you too. And that is the valence electrons. And this is one of the most important concepts I know in chemistry. I use it all the time. And you should know, what is a valence electron? A valence electron, those are the outermost electrons, are electrons in the outermost energy levels. Also say they're the outermost electrons of an element. So you should know that the valence electrons are the outermost electrons of an element. Those are the ones on the very outside of an atom. And I'll teach you how to know this. Notice I have, oh, it's Subtle Thursday. Hint, know this. You should know, what are the valence electrons? The outermost electrons of an element. If somebody comes up to you on the street and taps, well, not now because of the, unfortunately, the virus, but if somebody emails you and says, what's a valence electron? You better know that's the outermost electrons of an element. Well, how do you determine what they are? Well, you look at the group number at the top of the column of the periodic table are equal to the number of valence electrons that each element has in that column. Now, valence electrons are the same as the group number or number in the column, which is another way of saying everyone in the column up and down, I'll show you a periodic table in a second, have the same valence electrons. And the number of valence electrons is represented by the Roman numerals, which a couple of years ago I found most of my students now don't know Roman numerals. That's bad. They taught it to us in second or third grade, but they don't anymore. Or the standard numerical number on top of the periodic table that I'll give you. Now, this is important. The maximum number of valence electrons is 8. The minimum is 1. So if I ask you how many valence electrons does an element have, you put down 14, guess what? I'm going to laugh first and then mark it wrong, because you can't have more than 8. Can't have less than 1. So let's go to a periodic table. On test 1, 2, 3, 4 in the final, you'll be able to download this periodic table as a PDF file. If you notice, Dr. White wrote in red 1, 2, 3, and then over here 4, 5, 6, 7, 8. If you look underneath, say 4 here, IV is the Roman numeral 4. And I found out a couple years ago, most of my students didn't know Roman numerals. So that's when I did this and I wrote the numbers on top. What are those numbers? Those numbers tell you how many valence electrons all the elements in that column up and down, have. So if I asked you, how many valence electrons does lithium have? Well, first of all, you have to know the chemical symbol for lithium is Li. You look up here and you see the number 1, and the answer is 1 valence electron. If I ask you, how many valence electrons does sodium have? Well, it's in the same family or column Again, look on top. There's sodium, Na. It's 1. Now, if we look at magnesium, how many valence electrons does magnesium have? And we look on top here, and it has Roman numeral II, which is 2. But since you might not know it, I wrote till number 2. Magnesium has 2 valence electrons. Oh, I better share the fun. Your turn. How many valence electrons does calcium have? Time's up. Put down your pens and pencils. Hand in your monitor. No, anyways. Calcium, Ca. Number on top, 2. That tells you how many valence electrons. Therefore, calcium has 2 valence electrons. We come over here. How many valence electrons does nitrogen have? Here's nitrogen. Again, these are not the electrons total. These are valence electrons, which you come up here. Those are only the outermost electrons. And here, nitrogen, 5. Now, I'm going to let you have some fun. First of all, iodine. How many valence electrons does iodine have? Your turn. Go. See, people are already coming up with that. So I better tell you that. Remember, iodine is a halogen. And if we look on top, here it is, iodine I, and the Roman numeral VII, which you probably don't know, but I know it's 7. And here's 7. I wrote it both ways. I wrote it in red in case you couldn't see the one here in black originally. And if I ask you how many valence electrons does chlorine have? And chlorine is Cl. And again, it's the same in all the family column, 7. Now, if I ask you argon, how many valence electrons does argon have? Time's up. Argon, chemical symbol Ar. It's a noble gas. I almost said what I used to name it used to be inert gas, but it's called noble gas. And you look at top of the periodic, you see Roman numeral VII, I, which is 8, which I also give you. And you know argon has 8 valence electrons. So does neon, so does krypton. Now, helium is an exception, that's 2, but we'll talk about that later on. Other than that, everything's true here. So let's do one more. How many valence electrons does carbon have? Your turn to have some fun. I see everybody's already got the answer, so let's look at that. Where's carbon? Carbon has chemical symbol C. Look at the top of the column, you see the number 4, or IV, which is Roman numeral for 4, which many of you don't know. That's still sad. Anyways, and that's 4. And that's how you do valence electrons. And if I were to ask that test, 1 or 2 points each, oh, let's do one more. How many valence electrons does potassium have? Time's up. And the answer is potassium, chemical symbol K. Look on top, and the answer is 1. And thank you for all of you who are putting answers in chat. If you'd like to do that, go right ahead. If you don't, that's okay also. All right, let's continue on. Now, Why do I feel you should know valence electrons like you know your first name? Hopefully you all know your first name because they're important. The chemical properties of elements are largely determined by the number of valence electrons they have. Example, all the alkali metals, sodium, potassium, and lithium examples, have one valence electron, and that affects their chemistry. All the halogens have 7 valence electrons. Now, I'll teach you this again later on, but when you do a chemical reaction, reacting atoms together or molecules together, what interacts first are the outermost electrons, the valence electrons. And all the chemistry I've ever done and had fun with is I've been messing with valence electrons because the inner ones aren't affected. So all the things at chemistry to make things like, or happen in your body, like how does oxygen get broken down? What's the chemical, and we'll talk more about it. What is the structure of oxygen gas, O2? Why isn't it O5? That's all due to the valence electrons. That's pretty important. So the next time you think about why should I worry about valence electrons? Well, how many of you thought of water as a chemical? Hopefully you have. Or did you get hit in the face with the wind and that's oxygen, nitrogen chemicals hitting you? They're held together, and what determines that are the valence electrons. Pretty important. Yep. All right, I'm going to turn the switch off for the next couple of slides. There's something called the atomic radius, and that's the distance from the nucleus to the valence electrons. Remember, valence electrons outermost, and the atomic radius increases when you go down the periodic table, increases, and it decreases when you go from left to right. And for some things it's important. I rarely have used this, but in organic chemistry, we use it a little. This one, I won't have on a test right now, but I'll talk more about it. And that's called the ionization energy. And the ionization energy is the energy needed to remove an electron from an atom. And ionization energy decreases as you go down the periodic table and increases as you go this way. So it decreases this way, it increases this way. And therefore, of not including the noble gases, fluorine has the greatest ionization energy, which is the same trend as something we will call later on electronegativity. How strong does it want, this takes more energy to pull an electron off fluorine than say hydrogen or potassium. And that plays a role in its chemistry. That won't be on the test or the final. This one I'm going to skip. Uh-oh, the end. Nope, it's not the end of today. It's the end of the chapter. And you know what time it is, everybody? It's time for my whistle. It's time for a new chapter. A new chapter. Exciting times. Now you know I'm a chemist. All right, does everybody see chapter 5 on their screen? Thank you. Nobody's screaming at me. All right, this new chapter is about molecules and compounds. Now, I already went through this, but let's do it again. Remember, a chemical formula, a notion made up of symbols of the elements present. I'll never ask what's a chemical formula, but hopefully you understand. And there are numerical subscripts located right at the chemical symbol that indicate how many atoms each element is present in a molecule. See board. I can get lazy and write it here. Oh, here's one I haven't talked about. This is hydrogen peroxide. It's a bleach. In olden days, certain women who wanted to be blonde, I almost had a Freudian slip there. Blonde used hydrogen peroxide to make their hair blonde. And hydrogen peroxide is also very disinfectant, but it's a dangerous chemical you should be very careful with. And if I were to ask you, how many atoms in hydrogen peroxide? Your turn. And no, that's not water. They're different things. And the answer is 2 plus 2 equal 4. There are 4 atoms, 2 hydrogen, 2 oxygen. And I'd ask you, this is calcium bisulfate. I'd ask you, how many atoms are in calcium bisulfate? This is a 4. That looks better. Your turn. How many atoms are in calcium bisulfate? I give you another 14.6 seconds. Thirteen point 14, 14.1, 14.15. Time's up. And let's look at the answer. We have 1 calcium. Now, when you have brackets like this, whatever is inside the brackets, you multiply times the subscript to the right of the bracket. Remember, right, left. See, I don't leave any blanks open. But anyways, let's look at this. There's 1 calcium. Now, hydrogen, there's 1, but it's inside a bracket with 2. 1 times 2 is 2. Sulfur, there's 1, but we're in a bracket with subscript 2, so there's 2. Ooh, high level math time, get your calculators out. Oxygen, ooh, we've got 4. And 4 times the 2 outside the bracket is 8. And if I do my math, 1 plus 2 is 5, plus 8 is 13. My mother was an accountant. By the time I was in the end of 1st grade, I was expected to do this in my head quickly. She would drill us. And that's how you do it. All right, let's move on. Now, let's get into the juicy stuff about chemistry. When we talk about chemical compounds, there are 2 types. One is called ionic compounds, and the other is molecular covalent. Dr. White likes to use the term covalent. So there are 2 types of compounds, ionic and covalent compounds. Now, something I've used, but I should define, and I'll never ask this on a test, but I still like to define terms I use, a molecule. That's a group of 2 or more atoms that are functioning as a unit because the atoms are tightly bound together. What's an example of a molecule? Well, one you're all familiar with, water. Hopefully you've been drinking enough water, keep you hydrated. And water is a molecule, but you don't think of it. And when you drink water, you're drinking a lot of water molecules. I'll teach you later on how many. Another molecule is this, sodium chloride, which you know as table salt, or just salt. And if you ever go out with chemists, and I've been guilty of this many times, we'll ask one another, can you please pass the NaCl? And those are molecules. So next time you put salt on something, you're putting molecules of sodium chloride, NaCl on that, like on your French fries or whatever. I shouldn't have said that. Now I'm thinking of French fries. All right, now let's take a look at water again. H2O. How come that oxygen just doesn't say, hey, I'm tired of being here, I'm out of here, goodbye, and it flies away? Or what if one of the hydrogen says, I don't want to be here anymore, goodbye, I'm leaving? They don't. Why? Because of the chemical bonds. And chemical bonds are the forces that hold atoms together in more complex units. Water is a simple molecule, but I see a question from the, hold on one sec. All right, anyways, time to scare you. Look at your skin. Hopefully it won't hurt, touch it, go like that. You're feeling complex units of atoms held together to form your skin, which if you take organic chemistry, you'll learn that's proteins, your skin is, so is what hair I have left in my beard. And those are what holds the atoms together in your skin. Chemical bonds. You just have to look at your hand and you can see chemical bonds. And piece of paper. This is made up of complex units called carbohydrates, cellulose. What holds the atoms together in paper? Chemical bonds. And that's why, I don't know, I think I mentioned the first day of class, when someone says, I hate chemistry, which by the way, my sister does, my older sister, she doesn't like chemistry at all. She had a hard time in high school. Luckily, my father helped her out. He was a pharmacist and loved chemistry. Why did I become a chemist? Don't know. I'll think about that. But if you hate chemistry, then you won't be here. You wouldn't exist because you're made up of chemical bonds that hold atoms together in molecules. Hopefully I didn't scare you, and I hope you don't have any nightmares tonight about that, like your atoms falling apart. They don't. That's because chemical bonds keep them on together. Now, it turns out there are two types of chemical bonds that you should know. One is an ionic chemical bond. The other is a covalent chemical bond. In your skin, you have covalent chemical bonds, and I'll teach you more about ionic too. Water is also covalent chemical bonds, but you should know two types of chemical bonds. First one is ionic. Second one is covalent, two types of chemical bonds. Dr. White's getting serious because we're getting into serious stuff now. Now, what is an ionic bond? Ionic bond is what results from the transfer, or is the transfer of one or more electrons from one atom or group of atoms to another atom or group of atoms. Excuse me, I'm getting all choked up over this good stuff. All right, let me go through it again. What is an ionic bond? That's the transfer of one or more electrons from one atom or group of atoms to another atom or group of atoms. Time for Dr. White to get subtle. Hint, really know this. So again, what is an ionic bond? That's the transfer of one or more electrons from one atom or group of atoms to another atom or group of atoms. And that's an ionic bond. Remember, everything you see on the screen except what I write here, what's typed, is in Blackboard in my slides. And also, you can always come back and look at the video. Remember, Dr. White's a YouTube star. What is a covalent bond? A covalent bond is the sharing of one or more pairs of electrons between two atoms. Sharing one or more pairs. Remember, a pair means two. So, again, it's time for Dr. White to be subtle. Hint, know this. What should you know? Covalent bond. It's the sharing of one or more pairs of electrons between atoms. Ionic bond, you're giving up an electron or one or more electrons between atoms or group of atoms. Covalent bonds is always sharing pairs, and that's very important, one or more between atoms. So there are two types of chemical bonds. Ionic bond, you should know, is the transfer of one or more electrons from one atom or group of atoms to another atom or group of atoms. Yeah, know this. And covalent bond results from the sharing of one or more pairs of electrons between atoms. And that's a covalent bond. So when we look at all molecules in nature, in our life, in our universe, the atoms are held together in molecules, complex units, by either ionic bonds, covalent bonds, and I'll teach you later on, you can have in a molecule mixture of both. Ooh, let's get personal. How many of you washed your hands in the last 24 hours? Don't raise your hands or do a thumbs up. Hopefully you all did, because especially with COVID-19, it's good to have good hygiene. Now I'm being serious, but the soap you use, whether it's liquid from the bottle, that was pump bottle, or the bar soap, that molecules that are the soap have both covalent and ionic bonds in them. So next time you wash your hands, think about it. The molecules in the soap that are getting you clean. Yep, I'm clean. I washed my hands this morning. But anyways, that has both covalent and chemical bonds. And time for a commercial from Dr. White. Remember, when you leave my lecture, don't forget, think about chemistry. It's all around you. I stole that from SpongeBob. That's the episode where he goes, the Squidward, use your imagination. That's when they're stuck in a box. By the way, the more complex the mind, the simpler the recreation. Dr. White likes cartoons, even though nowadays they're not as violent and nice as when I was a kid. Back when I was a kid, there was a lot of murder going on in cartoons and action. Anyways, remember the molecules you're using in chemistry that you're learning about and things you're learning about in my class are all around you. And a commercial. Now, in the chapter, in the book, we have about nomenclature, how to name that. I'm going to skip this. I'm going to use some common names. By the way, there's an organization that was set up about 1918, right after World War I, that 135 or was it 138 countries, including the United States, signed to form an organization called IUPAC. I won't ever ask this on a test, but Dr. White likes to say IUPAC because it stands for International Union Pure and Applied Chemistry. And that's an organization in Geneva, Switzerland, that's main function in life is to develop and keep the rules for how you name all compounds, all chemicals. There's also something called common names, and I'll use both, but I'm not going to ask you. Again, it's the official source for all naming. Common names, things we use. I'm not going to go through ionic or covalent. I'll use them and you'll pick up some of them. All right, let's go through one more important thing, and that's polyatomic ions. Now, I'll teach you more about ions, but when you form ionic bonds and covalent bonds, you can have them both in the same thing. And that's when you have a polyatomic ion. Now, in chemistry, poly means, or anywhere, poly means many, atomic, atoms, and it's an ion. It's got a charge. By the way, I made this mistake years ago, being a chemist, and that is, at the other school, there was this dean. Unfortunately, she just passed away. She retired a couple of years ago, but she passed away. Very nice lady she was. Polly Nash was dean of English, and that area, who I knew at the other school through friends, I got introduced to her and her partner. And first thing I said, "Oh, Polly, do you know that name means many?" And she gave me that sort of look like, how many million times people have said that to me? Boy, I feel like an idiot, but poly means many. So if you know anybody named Polly, don't tell them that. They've heard it a million times, but now you know. Now, what are these polyatomic ions? Well, I won't go through the naming, but let's look at this chart. They're groups of elements that are existing together as sort of a little packet, or we call it a polyatomic ion. And if you have NO3 and a minus charge, it's charged, that's what makes it an ion. We call that nitrate. NO2 is nitrite. Another one, bisulfate, bicarbonate. And I'll ask you later on to know some of these names or just be familiar with it. Let's look at one in particular right now. This is the nitrate polyatomic ion. And it's weird why it changed colors on me, but it did. This molecule, which has both sodium and the nitrate polyatomic ion, is called sodium nitrate. Now, where do you find sodium nitrate? In packaged meats and prepared meats. It's used as a preservative. And also sodium nitrite, which is NO2, NaNO2. Now, next time you happen to pick up a package of bacon, hamburger, hot dogs, or other packaged meat, salami or anything that has the ingredients, near the end somewhere, you'll see either sodium nitrate or sodium nitrite, and those are added as a preservative. Now, time out for Dr. White personal opinion. Now, for a number of years, certain mother groups and other groups have said these additives are bad for your health and they cause all sorts of diseases in children. Well, I don't know. I can only speak personally. When I was young, and I still do, Dr. White loves salami and bacon. Shouldn't, but I do. And they're full of nitrates. And look what it did to me. Oh, you better stop eating it. But anyways, I don't think they're as dangerous, maybe for some people, but I can only speak for myself. Look how long I've been alive. more than a couple of months. So that's my own personal opinion. All right, when I look at the clock now, I'm going to do something different. Normally, I'd say let's take a 5-minute break, but since I can zoom through the lab in about 10 minutes or less, instead of having you come back in 5 minutes and say, why don't we just go straight through? Everybody hang in there. Let's go straight through and I'll let you out early. Sound good? All right, let's go through today's lab. Let me get it up. Oh no, I lost it. All right, since I've been playing with Zoom right now, everybody see the density lab? Thumbs up, people. You see it? Thank you. All right, today's lab deals with density. What is density? Well, it's an important physical property of matter, and it's defined by density as weight per unit volume, which I'll call Formula 1. Now, in this lab, you're going to be determining the density of certain items, and you'll use this formula. You'll find the weight, and you'll find the volume. Now, in order to save you money, I didn't have you go out and spend about $30 on a balance. You only use about 3 times with the kit. You've already spent money on the kit. So this is my own lab. I'm going to give you some numbers, or one number in particular, and others I've already given you, but you'll still get the same mental exercise and experience than if you were in the lab. Shh, don't tell anybody. All right, now, density is an important physical property, and an important aspect of density is lower density substances float in higher density liquids. Higher density liquids sink in lower density liquids. So let's take an example. If I had a big bucket of water and I had a cannonball, which is made out of lead, lead is more dense than water. I put the cannonball and drop it, guess what? Boom, it floats to the bottom. Now, if I had that same big bucket of water and I put a cork in there, dropped it, what happens? Cork has is lower density than water, and it floats on top. If you don't believe me, try these at home with your own bucket of water. If you have your own cannonball, I don't, but if you have a heavy object like a weight I pump iron, so if you know what I mean by that, I work out with weights. So take one of those weights, bucket, it's going to sink. If you have cork, like from a good wine bottle, by the way, Dr. White's favorite wine is German white wine from an area that I used to go to when I worked in Germany, and that's Pierce Porter, Golden Trocken, and either Cabernet, Spätlese, or Auslese. I love Auslese because it's very sweet white wine. They're much better than French white wines, my personal. Back to chemistry. Well, actually, that is chemistry, organic chemistry. But anyways, how many of you have ever seen the cork ring lifesaver, like in the movies, or they used to have them by bridges, sometimes in swimming pools, and somebody's drowning, you throw them that lifesaver ring. How does that save a person's life? Well, in there is cork, the old ones, and that is less dense, and that makes you less dense than water, and that way you float and you don't sink and drown. Now, if you look at life vests, they have material, and the ones in the airplane that you pull the thing and go, how do they keep you? The air or nitrogen inside is less dense than water, and that helps you be buoyant and not drown if you still are alive after you crash. That's disgusting. Bad Dr. White. But anyways, That's density. If you have two things and you put it, one say is a liquid and a solid or two liquids, the denser one always goes to the bottom and the lighter one floats on top. Now, how do you determine density of a substance? Now, to measure a density of a liquid or a solid, or in this lab, I'm also going to have you do an unknown, make it interesting. You first measure the weight of whatever you're going to determine the density of. In a liquid, you'd measure the weight first by difference, and you learned that in the lab you're handing in today about differences, how to measure by difference. And that is, you have an empty graduated cylinder, you weigh it, put it in the liquid, you weigh it again. The difference between empty and full is the weight of the liquid. And you won't do that, I'll give that to you. And then you measure the volume of the liquid. Now, here's a video I'll ask you to watch on your own, shows you how to do that. Now, for a solid, you use what's called water displacement. And here, you first of all, the solid you weigh so you can get the weight, and the volume is by displacement. Now, since I don't have any chemicals here, I won't put mine on. But remember, safety, when you're doing experiments, wear your goggles. All right, here's your graduated cylinder. If you have it filled about halfway full, and you want to figure the volume of a solid, you tilt it very carefully, put it in, slide it in. You don't want it to fall like that and splash out of here. You measure the volume before you put the solid in, and when you put the solid in, the volume will be higher. The difference between the two is the volume of that solid. Now, I'm going to show you later. I'm going to be making a change in the lab. I didn't check it. I should have. Hold on. Everybody know what this means? Shame, shame on Dr. White. Bad Dr. White. I have them there using a rubber stopper. It doesn't fit in here. At the other school, we have wider graduated cylinders, which it would fit in. I didn't realize it until last night. So we'll be using this from your kit, and I'll talk about that in a second. And here's a video on YouTube. I don't know if I told you everything's on YouTube except I think my high school graduation. But anyways, I would ask you to look at that too. Now, for today's lab, first of all, you're going to determine the density of octane. Octane is one of the chemicals in gasoline. No, you don't have it in your kit, but if you did, and if we were in the lab at COD, first of all, you'd find out the volume of the octane. And when you measured it in the graduated cylinder, the empty graduated cylinder weighs this. With the octane, 8.64 milliliters, weighs this. What's the weight, the difference? Then you have to calculate the density of octane. That's this difference, the weight of the octane, divided by this volume. And that's how you do it. Now, for you people, I'm not sparing any expense. I'm going really all out on you. So the next part, we're going to do the density of a diamond. Make sure at the end of the lab, you give me back my diamonds. Uh-oh, it's totally bad humor Thursday. And here now you have a solid. And first of all, you'll measure the volume of the solid by displacement. Here's the weight of the volume of water in your empty your graduated cylinder. When you put the diamond in, it goes to this volume. And the difference is the volume of the diamond. Since you don't have your scale yet, like never, I weighed out the diamond, and it's this. Remember, density is weight divided by volume and it's right here. Oh, by the way, make sure you give me back your diamonds that I gave you. Now here, I'm going to be changing this, and I'll upload it, or you just scratch it out. You'll be doing a copper strip, and wherever you see rubber stopper, put copper strip. So here, I'll just do it one place. You have a copper strip as a solid. You'll measure the volume by displacement and weigh. And well, I even made a mistake here. This should be copper. Copper strip directly. Put the copper strip on your balance. Well, you don't buy one, so I'll give you that in a second. Then you'll put in 50 milliliters in your graduated cylinder. This you will be doing. Record that volume. I'll show you how you tilt the graduated cylinder 45 degrees carefully and slide again, instead of rubber stopper, it will be the copper strip from your graduated cylinder. Record that volume. Again here, I'll be uploading this. If you already downloaded this, you don't have to, just I know what you're actually doing. And then keep the dried, return that, and clean up. Now, right here, your copper strip, it should be identical to mine. And I'll send this out in an email, is 11.0 grams. And you need this and these numbers here to get the density of that. Now, it's time for Dr. White to teach you. As soon as I find where, here it is. It was hiding on my desk. All right, here in your kit, you should all have a copper strip. You have a graduated cylinder. When you do this, put your safety guard. Notice I don't have any water in there, but assume you put water in here, fill it up to about halfway, record that volume. Remember, you should get 3 significant figures from here. Carefully tip this like this, take this, and slowly slide it down. And then this is going to go higher. That's your second volume. And it's the first one on the chart where it says the volume of the copper strip and that. And then the difference is the volume of your cup. Make sure you save this. Don't throw this down your drain. You'll clog it up. But anyways, that's how you'll do that part. And then you'll calculate the density. And you'll get, first you'll do about 50 milliliters and whatever number, 46, 48, 42, and then 0.0 or 0.5. Then here you'll put the strip in, and I'll change this later and I'll upload it. But you can, if you still have it, it's downloaded, printed it, just put a line through there, put copper strip. And the difference is the volume of your copper strip. Here's the weight. I'm giving that to you. I just saved you $30. And say, thank you, Dr. White. You're welcome. And divide this by this, and you'll get the density of the rubber stopper. Now, to make this lab exciting, part 3, density of an unknown metal. The DuPage County District Attorney needs to know the identity of an unknown metal in order to convict a person of a heinous crime. I'll let you fill in whatever heinous crime you want to put in there. And you must determine the unknown metal identity by determining the density of unknown metal, and thereby helping the DuPage County District Attorney convict that person of a heinous crime. Again, you fill in whatever heinous crime, murder, arson, other things. But anyways, those are pretty heinous. The unknown metal is a solid at room temperature. You'll measure the volume of your metal by water displacement. If we're in the lab, we actually do give you unknowns and you have to figure it out. But here I'm giving you the same mental process. You'll weigh the unknown, and here's the weight of the unknown right here, metal. Here's the graduated cylinder with water. When you put the metal in, here's the new number. The difference is the volume. Remember, weight divided by volume is density. Write that, and then put the identity of that from table 1. If you don't do this or get it wrong, I take off a point. Here's table 1. The unknown is one of these things. Also, these numbers will help you answer the questions. And for this lab, when you hand it in, this is due next Thursday. By the end of the day, I'll try and make it midnight Thursday. I think this week's I put down 10:30 p.m. Technically, I should have put down 1 o'clock p.m., but I didn't give anybody extra time. Some of you I know are working. And you'll need the stuff to answer the questions. And here are the questions. They're pretty straightforward. Example, determine which of the following substances will either sink or float when you put them in a bucket of liquid lead. And here are the items. And look and behold, here's lead, has this density, and you can find the other ones. And remember, densities with heavier densities sink in lighter densities float in heavier density things. Any questions about lab 3? Remember, this lab you're doing today that I just went over, or the next couple of days, whenever you do it in your home kitchen, make sure you wear eye protection, especially be careful of diamond. It's sharp edged. But anyways, do the lab. It's due next Thursday. The lab we did last Thursday is due by sometime today. Get it in, upload it through the assignment area Blackboard. And with that, I'm done. It's the end of the week for you people. You get a whole couple of days off and you don't even have to see me unless you come to my office hour, and you still get a couple of days off. But with that, I'm going to ask, are there any questions on the lab? Going once? Going twice? Oh, it's almost noon, and no, I'm not going to turn into a pumpkin. Actually, that's midnight. But anyways, with that, I'm going to wish you a nice rest of the day, rest of the week. I'll see you next Tuesday, unless you come to my office hour. I get to do this one more time. Have a great weekend. I'm done. Be safe. Gang gazoon. I'll see you next Tuesday, unless you come to my office. Bye. Or as Granny would say, bye.